Okay, Financial Math Grade 12 exam questions, November 2021. We are going to solve question 8 from paper 1 from DBE. Okay, this is the question 8 from November 2021 from DBE. The total is 16 marks. Okay, so let's get started on the next slide. Okay, let me get the question again. Question 8 from November 2021. Okay, this is the question. Question 8. Okay, question 8. 8.1. A farmer bought a tractor for 980,000 rand. The value of the tractor depreciates annually at a rate of 9.2% per annum. On the reducing balance method, calculate the book value of the tractor after 7 years. Okay, this question is 3 marks. Okay, 8.1. Calculate the book value of the tractor after 7 years. When you read the question, you can see the question says the value of the tractor depreciates. Okay, depreciates annually, meaning the value of the tractor decreases. And you have the interest rate is 9.2% per annum on the reducing balance method. It means the value of the tractor is reducing or decreasing. So you are going to use this formula, the compound decay formula. You can see instead of plus, you have minus, okay? Because you have depreciate and you have reducing balance method. So you understand you are going to have minus, okay? Depreciate and reducing balance method. You are going to have minus there, not plus. Okay, so the question is calculate the book value of the tractor after 7 years. Okay, this question is 3 marks. So this is our initial value, which is P. So P is equal to this, okay, our initial value. And you have N, which is equal to 7 years, okay, the number of the years. N is equal to 7 years. And you have the interest rate is 9.2% per annum. Okay, so I is equal to divide by 100. So this is 0.092. Okay, so now you have P, you have I, your interest rate, and you have N. The question is to find A, the book value, the final value after 7 years. So you are expecting to get a final answer which is less than this value. Okay, your final answer must be less than this value because the value is depreciating, okay, decreasing. So your final answer must be less than this value. So A is equal to, you are going to plug everything that you have into the formula. So this is what you have when you plug everything that you have into the formula to find A, the book value. Okay, so this is equal to, use your calculator. Let me use my emulator. So I have this. Okay, this is equal to this. Okay, you can see 498, 685, 82 cents. When you round off to 2 decimal places, okay, 82 cents. So this is what you have as your book value. You can see the value is less than the initial value, okay, you can see that. Now question 8.2. 8.2. How many years will it take for an amount of 75,000 to accrue to this amount in an account earning interest of 6.8% per annum compounded quarterly? Okay, from 75,000 to this. Okay, how long, how many years will it take this amount to grow to this amount in an account earning interest of 6.8% per annum compounded quarterly. Okay, the question is 4 marks. So you are going to use the same formula but with plus. Okay, you can see this is the initial amount and this is the final amount. You don't have an amount which is deposited at a regular period of time. Okay, you don't have that. If you have that situation, you are going to use the future value formula, but you don't have that situation. So you are going to use this formula but with plus. Okay, because there is an increase. You can see even the word accrue means increase. So you are going to use this formula but with plus. Okay, so this is the compound interest formula. Okay, compound interest formula. We are going to use this. So your initial amount P is equal to this, and the final amount is equal to this. Okay, you can see that from this to this. Okay, initial to final, and the interest rate is equal to 6.8% per annum. Okay, you are going to divide by 100, so you are going to get 0.068 over 4 because this is compounded quarterly. Okay, so now the question is to find how many years will it take for an amount, right, from this amount to this amount. How many years will it take this amount to grow to this amount? Okay, you have to find n. Okay, so plug everything that you have into the formula and solve for n. Okay, a is equal to this, right? This is a. This is equal to p. This is p. In bracket you have 1 plus I. This is your I, compounded quarterly. Okay, you close your bracket to the power of n. Remember, times 4. Okay, because this is compounded quarterly. So n is multiplied by 4. Okay, or you can leave n without multiplying it by 4. But remember, in the end, you are going to divide your final answer by 4. Okay, now let's carry on. You are going to divide by 75,000 on both sides so that you can have this part on its own. Okay, so you have this divided by 75,000. This is equal to, now you are going to divide this part by 75,000. Okay, you are dividing by 75,000 on both sides. So you divide by 75,000, you have this. This is equal to, you divide this part by 75,000, you are going to be left with this part. Okay, this part. You have this. Let me get the answer there in the brackets. So make sure you don't round off for now. Okay, let me see if I can get a short answer. So I have this. Okay, I didn't round off. So avoid rounding off before your final answer, because rounding off can affect your final answer. So you can see I didn't round off. Okay, so I have 1.017. Okay, 1.017. So this is to the power of 4n. Okay, 4 times n, 4n. Okay, let's carry on. Now we need to solve for n. You can see n is the exponent. For me to bring n down, I'm going to introduce log on both sides so that I can bring 4n down. Okay, so I have this. This is equal to, this can go down, 4n multiplied by this. Okay, like this. You bring 4n down, you multiply by this. Now you have this. Okay, let's carry on. Now we need to solve for n. Okay, you can see I'm going to need to divide by 4 log of this so that I can have n on its own. Okay, I'm going to divide by 4 log of this on both sides. Okay, so divide by 4 log of this so that 4 and 4 can cancel. and log of this can also cancel, and I'm going to be left with n alone. Okay, so what I do on the right, I'm going to do it on the left too. Okay, divide by 4 log of this. Now you can cancel 4 log of this. Okay, 4 and log of this, right? So now you have n alone. Okay, so n is equal to this. Okay, you have n left on the right side. N is equal to this. Now you are going to plug this in your calculator. Okay, so you are going to plug this. Close the bracket. Over this 4 log of this 1.017. Okay, this is equal to, round off to 2 decimal places, 6.5. Okay, 6.50, right? 6.5 or 6.50. Okay, so this is 6 years and a half. Okay, 6.5 years. Okay, so this is the final answer to question 8.2. 8.2. Now 8.3, right? 8.3. Dabo wanted to save 450,000 rand as a deposit to buy a house on 30th June 2018. 8.3.1, he deposited a fixed amount of money at the end of every month into an account earning interest of 8.35% per annum compounded monthly. His first deposit was made on 31st July 2013 and his 60th deposit on 30th June 2018. Calculate the amount he deposited monthly. 3 marks. Okay, calculate the amount he deposited monthly. Okay, when you read the question, the way this question is set, Dabo wanted to save this amount to use it as a deposit to buy a house on this date. Okay, you can see 2018. Okay, his first deposit, when you read this part, his first deposit was made on 31st July 2013. Okay, so he started in 2013 and he wanted to have this amount in 2018. Okay, so the way this question is set, you have to think about this question as if we are in 2013. Okay, and you want to have this amount in the future. Okay, and you can also see there is a monthly deposit. Okay, so 8.3 and 8.3.1, right? 8.3 and 8.3.1, you need to use this formula when you read the question, right? I hope you understand. He started in 2013 and wanted to save this in the future. Okay, so you need to use this formula. The question is to find X. Okay, calculate the amount he deposited monthly. To find this X, F, the future value, is this. Okay, Dabo wanted to save this. Okay, so F is equal to this. This is his target. This is what he wants to have in the future. Okay, and you also have N is equal to the number of payments. How many payments is going to make from this date to this date. You can see when you read this part, and his 60th deposit was made on 30th June 2018. Okay, in the future, from this date to this date in the future is going to make 60 deposit. So the number of payment N is equal to 60 payment. Your interest rate is equal to 8.35, right? 8.35% per annum compounded monthly. Okay, you are going to divide your interest rate by 12. So divide this first by 100. Okay, you are going to have 0.0835. When you divide this by 100, 0.0835, and then divide by 12, because this is compounded monthly. Okay, compounded monthly, you divide by 12. Okay, so now you have F, you have I, you have N. You need to find X, which is the monthly deposit. Okay, let me close this for now. You need to play with your formula. You need to do some rearrangement so that you can get your X. You can plug everything that you have in there and then solve for X. Or first, you can get X as the subject of the formula. Okay, so to get X alone on this side, I'm going to multiply by I over this. When I multiply by I, this I and this I, they are going to cancel. So it will be I over this part. So that this part and the same part at the bottom, they are going to cancel. So what you do on the right, you're also going to do it on the left. You're going to get X on the right side. Okay, this is equal to, you do the same on the left side. So this is what you get. F times I. Okay, so you have this. You multiply by I over this on both sides. Now plug everything that you have into the formula and get your X. So X is equal to, plug everything that you have into the formula. So you are going to get this. Okay, F, this is F, I, this is I, right? This is I over this, right? 1 plus I, this is I. You close your bracket to the power of N. This is N, okay, minus 1, minus 1. Okay, so X is equal to, plug this in your calculator. To the power of 60 minus 1. This is equal to this. Okay. 6,068 rand 69 cents. Okay. So this is the final answer to question 8.3.1. Okay. Let's move on. Okay, let me get the question again. Question 8 from November 2021. This is the question. Now it's question 8.3.2 and question A, right? 8.3.2 question A. Okay, 8.3.2, Dabo bought a house costing 1,500,000 rand and used his savings as the deposit. He obtained a home loan for the balance of the purchase price at an interest of 12% per annum compounded monthly over 25 years. Okay, compounded monthly over 25 years. He made his first monthly installment of this toward the loan on 31st July 2018. Now question A. What will the balance outstanding on the loan be on 30 June 2039, 21 years after the loan was granted? Okay, what will be the outstanding balance? 21 years after is left with 4 years to reach 25. So the balance outstanding on the loan will be calculated over a period of 4 years. So we are talking about the loan. You are going to use this formula, right? We are going to use this formula. I hope you know that. So X, the monthly installment is this, okay? And the interest rate is equal to 12%. 12 divided by 100 is 0.12. This is compounded monthly. So you are going to divide by 12 because this is compounded monthly. And N is equal to, is left with 4 years, right? From 21 to 25, 4 years. This is compounded monthly. So multiply by 12 and this is equal to 48. Let's carry on. Now the question is to find what? The outstanding balance on the loan. To find P for a period of 4 years. Okay, so P is equal to, plug everything that you have into the formula. This is what you get, right? Your X, this is X, 1. You have I there, this is I, negative N, this is negative 48. N is equal to 48 over I, this is I. So this is equal to, plug this in your calculator and let's see what the answer is. Okay. So this is what you have. Over this, this is what you have. Okay, right? 419, 419, 948, 948, 32 cents. Okay, 32 cents. So this is the final answer to question 8.3.2a. Okay, there is another method that you can use to solve this question. Okay, alternative method to solve question 8.3.2a. Okay, alternative method. Let's see. You can use this formula. The question is, what will the balance outstanding on the loan be on 30th June 2039, 21 years after the loan was granted? You can use this formula to find the outstanding balance 21 years after the loan was granted. You are going to take the balance outstanding on the loan 21 years after is equal to, okay, balance outstanding on the loan 21 years after is equal to amount accumulated, okay, accumulated amount of the loan 21 years after minus future value for 21 years. So the balance outstanding on the loan is equal to accumulated amount. This is A, the compound interest formula, minus future value formula. Okay, so you can also use this method to solve this question. You are going to find an answer which is close to this answer. So let's use this method. If you want, you can use this method or the one I'm going to show you now. But do not use both methods in the exam. Okay, so let's use this method and see if we can get the same answer. Okay, let me close this for now. So the balance is equal to, you have the compound interest formula, which is this one. I hope you know it, minus the future value formula, which is this one. We are going to solve for the balance outstanding on the loan 21 years after. Okay, so P, which is the initial amount. Okay, the initial amount. Remember, P is equal to the initial amount. When you check the question, the initial amount on which the loan is granted. Okay, P, right? accumulated amount of the loan. So your initial amount is not this one. Remember, he used his savings as a deposit. So it will be this one minus this one. You are going to subtract this from this. That will be the initial amount, because he did afford to pay this amount, but that was not the complete amount. He was left with some amount that was due. Okay, so the initial amount will be 1,500,000 minus what he paid, and this is equal to 1,050,000 rent. Right? Now you can plug everything that you have into the formula. You have I, this is I, N will be equal to 21 times 12, okay, compounded monthly. So you are going to have 21 times 12, X, this is X, N, 21 times 12, again, right, compounded monthly, I, this is I. So the balance is equal to, you plug everything into compound interest formula, you have this is your P, 1 plus I, this is I, to the power of 21 years times 12, right, 21 years times 12, because it is compounded monthly, minus, you plug everything into the future value formula, you have this, your X, this is X, right, in bracket you have 1 plus I, this is I, to the power of 21 times 12, right, compounded monthly, minus 1, over I, this is I, okay. So the balance is equal to, plug this in your calculator and let's see if the answer will be close to this. Okay, I hope you can follow. Remember to close the bracket. This is over this. Okay, you have this 419, 952, 39 cents. Okay, 39 cents. You can see the answers are very close. Okay, there is a difference of 4 rand. You can see the difference is 4 rand. Okay, so this is allowed. They will not penalize you in the exam. Okay, so you can use this method or this method. Please let me know in the comment section which of the method is your favorite. So let's move on. Now question 8.3.2b. Okay, 8.3.2b. Let me get the question again. Question 8 from November 2021. Okay, now calculate the interest Thabo will have paid over the first 21 years of the loan. 3 marks. Okay, so this is what you have to know. Total amount paid by Thabo in 21 years. Okay, total amount, total paid by Thabo in 21 years is equal to, when you calculate, you can see this is what is paying every month. So it's doing it every month, right? Every month, right? Times 12 for 21 years we want to know the interest for 21 years. Okay, times 21. Okay, times 12 because it's doing this every month. And times 21, we want to know for 21 years. Okay, so this is equal to, you're going to get, let's see, let me do this. Times 12 times 21. This is what you have. Okay, let me move the question. So this is what you have, right? 2 million. Okay, 2 million and something. Okay, so this is a lot. You can see as compared to the loan that was granted. The loan was granted for an amount of 1,050,000. Okay, 1,050,000. This, but now you can see this is what is paying for 21 years. Why is it so? Because of interest. Okay, because of interest. If you are granted a loan, you are not going to pay the exact amount. There will be some interest on top of that amount. Okay, so this is how it works in real life. So this is what he paid for 21 years. Okay, the question is to calculate the interest Thabo will have paid. Okay, we need to know the loan for 21 years. We need to know the loan for 21 years. This is what he paid for 21 years. We need to know the loan for 21 years. Okay, and then after that, we are going to take this minus the loan for 21 years. Okay, the loan paid by Thabo in 21 years. Okay, this is for 4 years. Okay, the outstanding, remember, from 21 to 25. This is for 4 years. Okay, let's remove for 4 years and we are going to get the one for 21 years. Let's get off this amount from the loan. This is for 4 years. This loan is granted for 25 years. Okay, let's get off the one for 4 years and we are going to be left with the one for 21 years. Okay, this is for 25 years minus the one for 4 years. Okay, this amount, you're going to have this when you plug into your calculator. This is what you are going to get. When you subtract the two numbers, you're going to get this. So the loan paid by Thabo in 21 years is equal to this. Okay, so the interest paid by Thabo in 21 years is equal to this, what he paid for 21 years, minus the loan granted. Okay, loan granted. Loan granted is this one. Okay, what he paid for 21 years minus the loan granted for 21 years. And this is equal to, so this is the interest that Thabo has paid in 21 years. Okay, so this is the final answer to this question. Okay, until next time, I will talk to you soon.